is only one perfect solution, but there are clues that will try to trick our team.
Hello there everyone, my name is Crazy Caleb, and today we're going to be taking a look at the color flash variants, and today we're going to be focusing on faulty color flash. Now, the display of the actual module of faulty color flash actually doesn't look any different from the normal color flash, but the catch with this one, and according to just how it looks immediately, one of the things that you'll realize between color flash and faulty color flash is a couple of the displays actually are going a little bit faster than they normally do on color flash. There is indeed going to be 8 different words present. This is not a very color flash, where there's only going to be 5. It's going to be the exact same amount as color flash. However, the catch with this is that if the display cycles through 8 colors at varying speeds, then this is going to be faulty color flash. So this is exactly what we're looking at here. So we're going to be taking a look at faulty color flash. And as you can see, some of these displays are going through rapidly fast, as you can see. So let's take a look and let's see what we need to determine for this module. This module itself is actually really easy to do. It's just the hardest part about this is determining the faster speeds. And it can be really easy to do, but sometimes it can also be really tricky. So what I generally like to do is I like to get the words and the colors and words. So let's do colors first. When it cycles back around, we've got magenta, white, blue, yellow, white. I'll get that again. Hold on. White, blue, yellow, yellow. Okay. And then for the words, yellow, green, yellow, blue, green, yellow. Nice and easy. Okay. So now, what we also need to do is we also need to check if these words are flashing at a faster speed. And the way that's determined is if they stick around for a short amount of time, that's going to be the way that they determine. And this is ultimately going to be a lot of practicing for how you exactly get the read. But essentially, they normally stick around for like a second, like a half a second, whereas these stick around for like 0.25. It's a really quick flash, which I think that the first one is actually a perfect example of one that is flashing at a faster speed. And I think that all 5 of these at the end are flashing at a faster speed. Let me check. Yeah. Okay. So this is the read that we're looking at here. So the normal speed is when it goes from the white green and the white yellow. That's the normal speed that you're usually going to get from color flash. However, with these fast flashes, these mean that these are going at a faster speed. So this is going to be how we're going to work with this thing. So let's take a look. So now what exactly are we going to be doing with this module? What we're going to do is each word can be broken down into a number from 0 to 3, which is the number of RGB components that are different between the word's color and the word itself. So for those of you who are familiar with the concept of Simon Sens, for example, or just any sort of module that uses what do we call it, the RGB component mixture here, what our goal is with this module, we're going to be trying to essentially figure out, hey, what's the difference here? What RGB components are different from each other? So we're gonna break this up, and I'm gonna allow these first couple ones to be an example here. But for the most part, I'm gonna do this in my head a little bit later on because this module is gonna be heavily dependent on this RGB components. So magenta is gonna be broken up into a red and a blue, and yellow is gonna be broken up to red green. So the ones that are different from each other, if we take a look, we're looking for components that are different between the word's color and the word itself. The reds are the same. They are both there and they are both present, so that is good to go. The blue and the green, however, are both different from each other, so this means that this value is going to be a 2 that we're going to get from this. And it's always going to be between 0 to 3 because obviously there is them being the exact same, or they are completely different from each other. They're completely polar opposites. So let's take a look. Now, the other thing, this is where the faster speed comes into play. If that word was flashed at a faster speed, then add 2 to this number. And in this example, this one was, so we're going to be adding 2 to this number to give us a 4. And we're going to essentially do this for each of these flashes and colors. And then what we're going to do is we're going to do some special things later on. So let's do the exact same thing again. So we have white and green. Now white is going to be made up of red, green, blue, and green is just going to be made up of green. Both of the greens are present. The red and blue are not shared with both of these colors. This is going to be another 2. And there is not a faster speed with this one, so this is just simply going to be 2. Same thing with white and yellow. White and yellow is made up of red and green, and red and white is made up of red, green, blue. The only difference here is going to be the blue, so this is going to be a 1. Now, let's take a look. Blue and yellow. Here we go. So blue is present, and then red and green make up yellow. All three of these components are different from each other. And the way that I can demonstrate this is we have dash dash blue, and then we red green dash. And as you can see, each of these happen to have different components. And now this means that this is going to be worth a 3. And since it was a faster speed, we're going to add 2 to this number, so this is going to be a 5. And now I'm essentially going to do this stuff in my head. This is the exact same thing that we had before, yellow and blue. We just had this one. So this is going to be a 5 because we're adding the faster speed. White and blue, we had this. It's a very similar case to the white and green. So there's going to be 2 differences, plus the 2 is going to be 4. Then blue and green. Now, here's where things get a little bit interesting with blue and green. This is where you want to make sure that things are important. So blue and green, they're both primary colors. But the catch with this is that there's a difference of 2. Not 3, 2. Both of them do not have the red component present. That is the key here. They both do not have the component present, therefore they are not different. However, the blue and the green are both present. Blue and green are present in each themselves. They are both different. This is going to be a 2. Plus the 2 from the faster speed is going to result in a 4. And then finally, yellow, yellow. These are the exact same. So this is going to be a 0 because there's no differences between these 2 colors. And this is going to be a, let me make sure I got that right. Yep, this is going to be a 0 plus the 2 is going to be 2. So now, with these numbers, what we're going to do is we're going to split these into pairs of 2. And as you can see by the tap code chart over here, you guessed it, we're going to get letters from these. Now, they're not necessarily going to form a word in this case because that's not what we're after here. So we have 4-2, which is Romeo. We have 1-5, which is Echo. We have a 5-4, which is a Yankee. We have a 4-2, which is a Romeo once again. Now, there's the possibility of there being duplicate letters. Now, one thing that's very important to note down is for those of you who are not familiar with tap code is the first number is going to be the pair is going to be the row, and the second is going to be the column. Very simple. And if one or both of the numbers are 0, then that pair represents K. So if there happens to be a 0 present at all in one of the numbers, that's just simply going to be 0. It's going to be K. It's going to be resulting in K. And now, what we're going to do is we're going to take the letter received from the first 2 words in the sequence, and then we're going to locate its row, first 2 numbers rather, locate its row on the table below. So now, we're going to find Romeo, and in this case, what this is going to give us is this is going to give us a series of characters or words, potentially, and if there is any other module on the bomb whose name, excluding spaces, contains anything in this row, we're going to press yes. Now, this is referring to specifically other modules in the bomb, and in the next example, I am going to load up some other modules in the bomb to show you how this works. But there's this little asterisk next to it, and the asterisk is very important. If this is the only module on the bomb, use this module. So you want to make sure that you're focusing on other modules if there are other modules present. However, in this case, a faulty killer flash being the only one on the bomb, you're simply going to be focusing on this one. So what we're going to do is we're going to essentially figure out, hey, is there any characters with an and, hash, question mark, or an exclamation mark? And in this example, this is going to be no. We do not have any of those characters present in Faulty Color Flash. We are now going to press no for this one. And we're going to do the exact same thing for each of these other 3 characters present, and that's going to be how we're going to solve this module. So now, Echo. Press, tap, hold, mash. Not present in Faulty Color Flash, not true, so we're going to press no for this one. Okay? Yankee. Forget, memory, amnesia, elder. Nope, not true. And finally, for Romeo, once again, we are to determine this one. This one's also going to be a no. And just like that is a solved module. And that's all you are simply doing with this module. It's a quite simple module. It's just getting that read can be a little bit tricky. The work itself, though, not too bad. So let's take a look at one more example. I want to go on to a bomb with some more modules here and see what we can get to make it maybe mix things up a little bit. And of course, see what happens. Now I'm hoping I get lucky with the modules that I get pulled, some more common ones with like names, like for example, Boolean, word, letter, character, red, blue, green, yellow, stuff like that. That's going to be what we're looking for here. So let's take, let's do 5. Let's do 5 times all mods. Go down here, 5 times all mods. And let's just see what the heck we get. I have so many modules installed, I have actually no idea what's going to be coming here. So let's take a look. We get video poker, we get manometers, third base,
Trick our team.
1D maze, that's going to be a good one. That's going to be helpful. Entry number 4. Hopefully there's some stuff that was present in here. But now let's just focus on this for right now. So let's focus on the colors first, and then let's focus on the words second. So we've got blue, yellow, magenta, yellow, blue, yellow, white, blue. Okay, and then words: green, blue, white, white, red, blue, blue, and yellow. Okay, and now for faster speeds. This is going to be a bit interesting. So let's take a look and see what we have here. So we have the sequence to restart. 1, 2 felt faster. And then the last 3 felt faster? Yeah, that was a nice and easy one. Okay, so the first 2 were the faster ones. The last 3 were the fast ones. Okay, perfect. Now let's do some stuff with this. So, first things first, let's start breaking up the RGB components of this. Blue and green, only a difference of 2. They both do not have red present, so that's going to be 2, plus the 2 for the faster speed is going to be 4. Yellow and blue, these are polar opposites. Yellow contains red and green, and blue contains just blue. These are polar opposites. This is going to be a 3, plus the 2 is going to be a 5, and just like that, that's good to go. Next up for magenta and white. Let's take a look. That's going to be, so there's red and blue for that, and then there's going to be, for magenta, and then there's going to be red, green, blue for white. There's a difference of 1 in these guys. And then the same thing for yellow. Yellow is made up of red, green, and then white is made up of red, green, blue, difference of 1. Blue and red, difference of 2. They're both primary components, and both of them do not have green present. There we go. Same thing with yellow and blue. Just before we had the same exact case. That's going to be a 5 because of the faster speed. White and blue, that is a primary component compared to a RGB component. They both do share the blue component, but red and green are different. So that's going to be a 2 plus a 2 is going to be 4. Blue and yellow is going to be polar opposites again. We have these exact same case. That's going to be a 5. Faster speed. In this case, it would be normally 3. However, it's going to be 5. So now we have our characters. Let's convert these from tap code into letters. So we have 4, 5. 4, 5 is going to be a uniform. 1, 1 is going to be an alpha. 2, 5 is going to be a Juliet, and 4, 5 is going to be a, once again, uniform. So now, let's take a look. Now, with this in mind, we have other modules on the BOM. We are not going to be comparing faulty color flash to anything that we get. Keep that in mind. So if we happen to, for example, had a T, for example, if you take a look here, faulty would be present. If there was a T, we would say no to this because of the fact that we do not have any other faulty modules. And in this example, faulty color flash would be the only one. We want to compare any other module on the BOM. We do not care about this one for right now because it is not the only module on the BOM. Very important to remember. So let's take a look. So we've got uniform. Uniform wants me to take a look at wire, button, maze, and Simon. Well, we actually happen to have 1D maze present on here. That's going to be perfect. So this is going to be a yes. Alpha. 1D. Well, we happen to be getting both of them. Fantastic, because we have 1D maze right here. This is indeed going to be present. Juliet, let's take a look. Juliet wants me to take a look at binary, ternary, 0, and 1. So we've got third base, we've got video poker, we've got 1D maze, we've got manometers, and we've got entry number 4 or 1. Actually, let me check. I'm not sure which one this is. Is it the upside down one? Entry number 1 or entry number 4? Entry filters, please. I need to turn back on the tutorials. Entry. Which one is the upside down one? Is it entry number 1? Let's take a look. Display slightly corrupted. I need to make sure of this. I'm just going to check the logging just to make sure I get this right because it doesn't specifically state it in the text. And they're both basically the exact same concept. I just want to make sure I get this right. It is entry number 1. Yep, I had 100 was entry number 1. So, with this example, we do have 1 present in this name. I don't know this module well enough, so sorry about that. So this is going to be a yes for Juliet. And we've already determined that uniform was a yes from this first one. That doesn't change anything. That's going to be a yes. And now, with this one, we're going to be pressing yes, 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 yes. And just like that is a solved module. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.